GPT 5.4 Nano is 200 times faster than GPT 4, and OpenAI buried this in a footnote.
200 times? That can't be right for the same quality output. So we're breaking down the benchmarks, the actual use cases, and where these models beat their bigger siblings?
By minute 4, you'll know exactly which model to switch to tomorrow. Let's get into it.
Welcome to the AI Daily Podcast, today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into introducing GPT 5.4 Mini and Nano.
Stick around to the end for today's headlines. Let's dive right in.
So, OpenAI just dropped GPT 5.4 Mini and Nano, and honestly, this might be the most important release they've had in the past year. Not because these models are more powerful, they're actually less powerful than the flagship GPT 5.4, but because they represent a fundamental shift in how we're thinking about AI deployment.
Right, I saw those benchmarks. GPT 5.4 Mini is hitting 54.4% on SWE Bench Pro compared to the full model's 57.7%. That's surprisingly close for what I assume is a much smaller model.
Exactly. And that's the story here. We're seeing this fascinating inflection point where the industry is moving from how big can we make these models to how small can we make them while keeping them useful. The mini version runs more than twice as fast as GPT-5 Mini, and the Nano model, which is their smallest yet, is still hitting 52.4% on SWE Bench Pro.
Those Terminal Bench 2.0 numbers caught my eye too. The full GPT 5.4 hits 75.1%, Mini gets 60%, and Nano manages 46.3%. For context, GPT-5 Mini only hit 38.2%, so we're talking about significant improvements even at the smallest tier.
What's really happening here is OpenAI is responding to what developers actually need. Think about it. If you're building a coding assistant that needs to respond to keystrokes in real time, or you're deploying thousands of AI agents to handle customer service, you can't afford to run the full GPT 5.4 model for every request. The latency would kill your user experience, and the costs would destroy your margins.
And they're specifically calling out coding assistants, sub-agents, and computer use systems. Those OSWorld-Verified benchmarks are interesting too. Mini actually gets 72.1% compared to the full model's 75%. That's remarkably close for computer interaction tasks.
Right, and this ties into a bigger trend we're seeing. The era of one model to rule them all is ending. Instead, we're moving towards specialized models optimized for specific use cases. If you look at what developers are actually building, coding copilots, autonomous agents, real-time multimodal applications, they need models that can respond in milliseconds, not seconds.
But here's what I'm wondering. Are we seeing diminishing returns on model size? Because if a mini model can get 94% of the performance at half the size and twice the speed, why would anyone use the full model?
Great question. And it really depends on your use case. For complex reasoning tasks like advanced code generation or scientific research, that extra 3 to 5% accuracy might be worth the computational cost. But for the vast majority of applications, you're absolutely right. The mini and nano models are going to be the workhorses.
The pricing is going to be crucial here. They haven't released specific numbers yet, but if historical patterns hold, we could be looking at 5 to 10x cost reduction compared to the full model.
And that changes everything about AI adoption. Suddenly, startups that couldn't afford to build AI features can experiment. Small businesses can deploy customer service agents. Individual developers can build and scale AI applications without venture funding.
Coming up, we'll dig into exactly how they achieve these performance gains and what the technical trade-offs really look like.
So let's talk about what's actually happening under the hood here. OpenAI hasn't released the full technical details, but based on the performance characteristics and some educated guesses from the research community, we can piece together their approach.
The speed improvements are massive, over 2x faster than GPT-5 Mini. That suggests they're not just doing simple model distillation. They've probably re-architected the attention mechanisms, maybe using techniques like flash attention or even more aggressive optimizations.
Exactly. And when you look at the benchmark results, there's a clear pattern. The mini model maintains nearly full performance on tasks that require reasoning and tool use. It's at 42.9% on Toolathon compared to the full model's 54.7%. But where it really shines is in maintaining that performance while dramatically reducing computational requirements.
The GPQA Diamond results are fascinating too. Mini hits 88% compared to the full model's 93%. For a graduate-level reasoning benchmark, that's remarkable retention. It suggests they've found ways to preserve the model's core reasoning capabilities while stripping out, what, redundant parameters, less used knowledge?
That's the million-dollar question. One theory is they're using a technique called structured pruning, where they identify and remove entire attention heads or layers that don't contribute much to performance on target tasks. Another possibility is they're using knowledge distillation, but with a twist, training the smaller models specifically on the kinds of tasks they'll be used for.
The Nano model is where things get really interesting, though. Look at those OSWorld-Verified scores. It drops to 39% from Mini's 72.1%. That's a huge cliff. But for Toolathon, it maintains 35.5% compared to Mini's 42.9%, much more gradual decline.
Which tells us the Nano model is specifically optimized for tool use and API interactions, rather than complex visual reasoning. And that makes perfect sense for their target use cases. If you're building a swarm of coding sub-agents, you need them to reliably call functions and manipulate code, not necessarily understand complex diagrams.
Speaking of coding, those SWE Bench Pro numbers are incredible. The Nano model at 52.4% is outperforming what GPT-4 could do just 2 years ago. We're talking about a model that's probably 100x smaller, solving real GitHub issues at over 50% success rate.
And here's where it gets really interesting for platform engineers. These models are small enough that you could potentially run them on-premise or at the edge. Imagine having GPT 5.4 Nano running locally in your IDE, providing instant code completions without any network latency.
But what about the trade-offs? There have to be scenarios where these smaller models fall apart.
Absolutely. The Terminal Bench 2.0 results show the limitations clearly. The Nano model drops to 46.3% from the full model's 75.1%. So for complex terminal operations requiring deep system understanding, you'd still want the larger model. And I'd bet anything requiring extensive world knowledge or creative writing would show even bigger gaps.
The multimodal capabilities are another consideration. They mention these models can do real-time image reasoning, but at what resolution, what complexity? My guess is they've significantly reduced the vision encoder size, which would limit fine detail understanding.
Right, and this brings us to the deployment considerations. If you're building a system that needs to handle diverse tasks, you might need a router that sends simple requests to Nano, moderate ones to Mini, and only the complex stuff to the full model. That adds architectural complexity, but could reduce costs by 80 to 90%.
The latency numbers they're claiming, 2x faster than GPT-5 Mini, that puts us in the sub-100 millisecond range for most queries. That's game-changing for interactive applications.
Exactly. At those speeds, you can start building truly responsive AI experiences. Think about coding assistants that can analyze your entire codebase and suggest refactors as you type, or customer service bots that can handle multiple conversation threads simultaneously without lag.
But here's what worries me. If everyone starts deploying thousands of these nano agents, what happens to API reliability? OpenAI's infrastructure is good, but can it handle a 100x increase in request volume?
That's a great point. They'll need to have thought through rate limiting, queuing strategies, and probably geographic distribution. My bet is they'll push hard for enterprise customers to use dedicated instances rather than shared API endpoints.
Stick around. In our final segment, we'll break down exactly how to choose between these models and give you a practical decision framework for your own applications.
All right, let's get practical. You're a platform engineer, you've got an AI project, and now you need to decide full GPT 5.4, mini, or nano. Here's the framework I'd use.
First consideration has to be latency requirements, right? If your application needs sub-100 millisecond responses like autocomplete, real-time translation, or interactive debugging, Nano or Mini are your only realistic options.
Exactly. And here's a specific rubric. If your P99 latency needs to be under 200 milliseconds, go Nano. Under 500 milliseconds, Mini works. If you can tolerate 1 to 2 second responses, then consider the full model. But remember, these aren't just about raw speed. It's about user perception. A coding assistant that takes 2 seconds to respond feels broken, even if it gives perfect answers.
Cost is the other big factor. Let's say Nano costs 0.0001 per 1,000 tokens, Mini costs 0.005, and Full costs 0.05. For a typical coding assistant handling 1,000 requests per user per day, that's $1 versus $5 versus $50 per user per day. The economics completely change your business model.
Right, and this is where you need to think about your use case hierarchy. Here's what I'd recommend. Use Nano for all your filtering, classification, and routing tasks. Use Mini for the actual work, code generation, analysis, refactoring. Reserve the full model for only the most complex tasks, where that extra 5% accuracy really matters.
Can you give a concrete example?
Sure. Let's say you're building a PR review system. Nano models scan every commit for basic issues, syntax errors, obvious bugs, style violations. They're fast and cheap enough to run on every single commit. Many models handle the actual code review, understanding logic, suggesting improvements, checking for security issues. The full model only gets invoked for architectural reviews or when the mini model signals low confidence.
That's smart. You're essentially building a cascade of models. What about fine-tuning? Should teams be thinking about customizing these smaller models for their specific domains?
Absolutely, and this is where things get really powerful. A fine-tuned nano model trained on your specific codebase might outperform a generic full model for your use cases. OpenAI will likely release fine-tuning for these models within months, and when they do, that's when we'll see the real explosion in specialized AI agents.
What about deployment patterns? Are we talking about direct API calls, or should teams be thinking about caching, edge deployment, maybe even local hosting?
Great question. For nano models, aggressive caching makes sense. Cache common queries, code patterns, even partial responses. For mini, you might want regional deployment to minimize latency. And here's a pro tip. Implement request batching. These models are optimized for throughput, so sending 10 requests together might be faster than 10 individual requests.
But what about reliability? If everyone's building agents with these models, API availability becomes critical.
This is why you need fallback strategies. Primary, nano model for speed. Fallback, mini model for accuracy. Emergency fallback, cached responses, or even older model versions. And always implement circuit breakers. If the API is struggling, gracefully degrade rather than failing completely.
Looking forward, where do you see this going? Are we heading toward even smaller models, even more specialization?
I think we're going to see an explosion of tiny, specialized models. Imagine models trained just for Python, just for JavaScript, just for SQL. Models optimized for specific frameworks or libraries. The future isn't one giant model. It's thousands of small, highly optimized models working together.
And that changes the entire AI development paradigm. Instead of prompt engineering for a general model, we're talking about orchestrating specialized agents.
Exactly. The skill set changes from how do I write the perfect prompt to how do I architect a system of AI agents. It's more like microservices than monoliths. And just like microservices, you'll need service discovery, load balancing, monitoring, all of that infrastructure.
So for teams listening, what should they do today?
3 things. First, audit your current AI usage and identify where latency is killing your user experience. Those are prime candidates for Nano or Mini. Second, start experimenting with agent architectures, even simple 2-tier systems with Nano for filtering and Mini for processing. Third, prepare your infrastructure for 10 to 100x more AI API calls, because these cheaper models will change the economics of what's possible.
This really does feel like a pivotal moment. We're moving from AI as a special feature to AI as a utility.
That's the perfect way to put it. Just like we don't think twice about making database queries or API calls, we're approaching a world where AI inference is just another system call, fast, cheap, and reliable enough to build into everything. The question isn't whether to use AI anymore, it's which AI to use for which task. Before we wrap up, let's catch up on this week's infrastructure news. There is a troubling development in the AI safety space. Elon Musk's xAI is facing a lawsuit from miners who claim the company's Grok AI allegedly generated inappropriate images of them. According to TechCrunch, the plaintiffs are saying xAI failed to implement basic safeguards.
This raises serious questions about content moderation in AI systems. How did Grok even have the capability to do this without proper guardrails?
Speaking of AI challenges, Joy Eberts presented an interesting framework at QCon London for managing technical debt in the age of AI-generated code. InfoQ reports she's developed 6 key questions to help teams prioritize which debt to tackle first.
That's timely. With AI pumping out code faster than ever, we're probably creating technical debt at unprecedented rates. What's her main insight?
She argues that not all tech debt is equal. Some actually helps you move faster, while other types slow everything down. Meanwhile, Encyclopedia Britannica and Merriam-Webster are taking OpenAI to court.
Another copyright lawsuit?
The Verge reports they're claiming GPT-4 essentially memorized their content during training. Britannica says the model can reproduce their articles almost verbatim, which they argue proves unauthorized use of their copyrighted material.
That's going to be a fascinating legal precedent if it goes to trial. How do you prove an AI memorized versus learned from content?
On the technical front, there's a breakthrough in LLM control. Researchers just published a paper on Archive about style modulation heads. They've identified specific attention heads that control persona and writing style in language models.
So we could potentially have more fine-grained control over how AI systems communicate.
Exactly. They can modify just these heads to change the entire personality of the model. Finally, despite the Pentagon labeling Anthropic a supply chain risk, Axios reports that tech companies aren't backing away from partnerships with them.
Interesting. So the market demand for Anthropic's models is strong enough to override security concerns.
Apparently so. Enterprise contracts are actually growing, suggesting businesses value the capabilities more than they worry about the Pentagon's assessment.
That's quite a statement about the current AI landscape. That wraps up today's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.